Hello, and welcome to another episode of Earth911's Sustainability in Your Ear. I'm Mitch Ratcliffe. It's good to be back with you folks. We're here to talk about a really pressing issue. The electrification of the economy depends on reliable access to a collection of valuable but environmentally damaging metals, including lithium, cobalt, nickel, and manganese. If we can recycle these things, we can continue to develop an electrified economy without doing as much damage to the environment. And so it's critically important. Our guest today, Megan O'Connor, is the co-founder and CEO of Nth Cycle. It's a Beverly, Massachusetts-based startup poised to disrupt the metal recycling industry with an electro-extraction system. The Nth Cycle process can handle up to 5 tons of material each day and in a very compact facility, only about 1,000 square feet, which is roughly half the size of the typical retail storefront. That means, in theory, that materials could be recycled near the source and even potentially reused locally. The technology also will help to extract more metal from ores and post-processing wastes that have been discarded by mining and smelting companies for decades. So Nth Cycle recently took second place in TechCrunch's Startup Battlefield competition, which is a very significant accomplishment and has raised $4.5 million. You can learn more about Nth Cycle, which is NTHCYCLE, nthcycle.com. Megan, welcome to the show. How are you today?
Hi, Mitch. Great. Thank you so much for having me on today.
Well, the reason that this caught my attention was recycling is usually a very messy, capital-intensive business that requires a lot of land, but your approach seems to break the mold. How does the Nth Cycle system work?
That's a great question. And that is exactly what I saw and the reason why I decided to go down this path and develop a technology, because you're right, it is very capital intensive generally to recycle materials. And that was very, one of the things that was actually deterring people from recycling, especially in the electronics sector where all these batteries are. And so the way the Nth Cycle technology works, I like to think of it as an electrified Brita filter. So it is a carbon filter that filters water that we figured out a way to safely electrify. And by pushing different electrical currents across that carbon filter, where we're filtering out these different battery metals, we can actually select and remove copper, cobalt, nickel, manganese, all the really, again, valuable critical materials that we're going after very selectively to then get them back into the supply chains for remanufacturing.
So you're using water and carbon to do this filtering. There's no chemicals involved?
Very, very few chemicals, and we can actually recycle them 100%. So it's a very, very closed loop chemical process, we call it.
Okay, so no byproducts that are polluting. That's great. Now, the other big part of this is the capital required to get started. How does this compare to traditional recycling processes in terms of just the upfront cost of starting to do it?
So the technology that they use today for refining materials in general costs anywhere from $500 million to set up these facilities, anywhere up to $1 billion. So they are, a massive investment. And the U.S. really hasn't invested in any of that infrastructure over the past 50 years, which is why it's so hard and so expensive for us to recycle here, is because we actually have to ship all of that material overseas to be recycled, where they actually did invest in these, again, massive refining or recycling facilities.
that speaks volumes about the nature of U.S. policy. But just taking the shipping out of the equation is an incredible benefit in terms of carbon impact. How local can recycling really be, particularly when you think about where the material is going to go back into use when you're talking about batteries and electronics? Is it feasible in an environment where things may be 3D printed on demand right near the customer to think about keeping a local circular economy in these metals?
Absolutely. And that's actually where most of the scrap materials like batteries and cell phones and things end up, are at very local collection facilities. And these folks, right, are generally family-owned businesses that have been around for a couple decades, collecting this scrap, trying to get as much value out of it as we can. But again, they don't have and never had to have the capacity to chemically recycle these materials into the individual metals, which again is what Nth Cycle is trying to do and help them with. So we can actually go on site, help these folks chemically extract the materials in a much safer way so that we can then reuse them right in that same area. So we don't, again, have to transport them across overseas or even across the country to be able to reuse those materials.
So is your business model predicated on operating recycling facilities or providing the equipment and services to recyclers?
Great question. So we actually go and own and operate our assets on site. So provide more of a service to these customers, again, who simply collect the material and don't necessarily have the background or the capacity to be able to recycle them themselves. So that's the true service value we bring.
Now, just thinking about these local facilities, how many people does a typical installation employ, just in terms of thinking of local economic benefits?
Yes, absolutely. And that's something we thought a lot about. So with just our system alone, we plan to hire at least 2 to 5 people per system we put on site. So the way that our technology works is we can actually, because it's so small and modular, we can add units in parallel to accommodate larger feedstocks as the market grows, or if we go after larger projects, say in the mining space. So we plan to really invest the time and the resources there to increase the jobs around the site.
So are you going to open dozens of facilities, hundreds of facilities? What's your growth plan look like?
Yes, over the next couple of years, targeting up to 100 different recycling facilities, and then going after some of the larger mining projects. So again, really trying to tap into as many of the natural resources we have here, but in a safe, cost-effective way. So trying to significantly reduce the carbon footprint that current mining and refining techniques have today, to try and access all the cobalt and nickel that we have here. Because unfortunately, even if we're able to recycle all of the scrap that's available in the States, it would still only provide us with about 10% of the total projected demand for cobalt and nickel. So we still have to find alternative resources for the cobalt and nickel to meet our electrification goals by 2030, 2040.
So this is interesting in terms of thinking about our infrastructure. You've got this disruptive, close to the edge process, but we have an infrastructure designed around, while it is distributed, centralized collection locations that often use very antiquated processes. So, for instance, there was a new EU research report this week out about recycling lithium batteries. And the point was made that most cars get shredded with the system, the whole car gets shredded, where the battery should be extracted so that it can actually be recycled beforehand. So do we need to rethink how we collect electronics and disassemble them before we, especially when you get to cars, before we can really implement local recycling at scale?
Absolutely. And that is one of the things that I think a lot of companies in this space are looking at now, is how do we effectively get these batteries and other types of scrap into a place where we can recycle them, and it can still be distributed. But right, like you said, we need to be able to figure out how to dismantle them much more efficiently, because right now, the most cost intensive part of the process is actually in the disassembly. So just think about when these folks get an EV pack back, there's literally a person in, head to toe, personal protective gear, dismantling this battery. It takes them, a whole 8-hour shift to dismantle one pack. So you can imagine when like thousands, if not hundreds of thousands of these packs are coming off the road in 2030, 2040, right? It's just not feasible. And so we need to develop and really push resources into figuring out exactly what you said of how to dismantle and collect these safely. And so those are the folks that we're currently working with too at a larger scale, is, really helping them think through that strategy.
This really underscores the point that there is an immense economy in local processing that has yet to emerge. Now, the small footprint, the physical footprint of your system makes it a lot easier and less expensive to create these local circular economies. Can this technology be easily co-located at a transfer station, for instance, a municipal transfer station where people are dropping this material, and then you could direct it to your facility?
So we thought about that. We don't have any near-term projects in that space, but have thought about different partners we could bring who could help us collect that material locally and just transfer it to a place where then we could tackle it and chemically process that into new battery materials.
So as we rethink our infrastructure, do you recommend that local governments think about looking at projects like what we're talking about, a hyper-local metal recycling process location?
Absolutely. Absolutely. I think it could definitely be feasible for a lot of the cities, right? And if you think about even the future of just not, EVs, but also sort of the e-mobility space with all the scooters and things out there now, a lot of those are already hyper local, right? I mean, these companies go into specific towns, specific cities, and then the battery packs last, maybe 2 years at best. So they have a much shorter lifetime than when you think about what an EV is projected to last. And so just in that space alone, there's been a lot of thought and strategy around how do we keep those materials local, keep that circular economy, right there so that we can directly reuse these materials, say into a new scooter or into some other type of battery that can go right back into that same town and make it a much more sustainable process overall.
So a moment ago, you mentioned that we really only have about 10% of the available or needed material out there. Is it possible that we could start to mine our landfills for these materials? Because we've dumped so many batteries and other things into the ground over the past 60, 70 years, well, more than that. Are we sitting on, so to speak, a gold mine of recyclable material?
Yes, I like to think of it as urban mining, right? I mean, we're going into and trying to find all these valuable materials in products because there's actually a much higher grade of materials in, scrap materials than what you'd see in raw ore, right? In raw ore, you maybe have 1% of valuable metal in all this dirt and rock. Whereas in a battery, for example, there's 20 to 30% of super valuable material that's in there, yes, like you said, that are in landfills. So yes, I think we could go in, and even just over the past 5 years, right, there's been more lithium-ion batteries that have come out of consumers' hands. And right, a lot of states don't have the regulation to say that e-waste has to be recycled. So it does end up in a landfill. So yes, I do think that there's a lot of potential in a lot of the different landfills around different states.
So the other question that occurs to me as I think about that shortage of material in the first place is, should we be thinking about creating national policy to import e-waste from other locations instead of what we've been doing for a long time, which is sending it overseas?
It's an interesting question. So a lot of the development work that needs to be done here before we can, I think, even answer that question is can we stand up the infrastructure to process our own e-waste? Because like you said, the practice that we've had over the past several decades is simply exporting it over to Asia or India. So it's definitely a big issue that people are thinking about. And I think we have the resources that we need here. Again, we have the cobalt, copper ore bodies. We have the nickel ore bodies. We just really haven't been able to access them because it's such a low grade of material and traditional mining processes are so hazardous. We really haven't been able to tap into those resources. So I think we have them here in North America and really need to figure out our waste management strategy moving forward to continue to keep those minerals in circulation.
So do you envision potential partnerships with electronics firms, EV and battery manufacturers as a way to create their own circular economy in materials?
Absolutely. And those are the partner facilities we're talking to now, right? The auto OEMs, the big electronics manufacturers, they are really looking forward to being able to fully recycle all their materials. And I think a lot of the thought that is going into it now is how do we track these materials through their life, right? How do we, say, Ford or GM, right? How do they know where their packs end up at their end of life so that they can get that material back? And so I think they're working with a lot of us across that value chain to really help them sort of drive their strategy moving forward.
Do you think that could also entail something like a deposit system on the recyclable components of your car, for instance?
I do. Yes. I think that's one of the strategies they're thinking about moving forward. And I know there are companies today that are thinking about that very near term, actually.
Interesting. Now, I wanted to ask just a couple of practical questions about the process because they're interesting terms. And one of them is black mass, which is a product of the battery recycling process. What is it and what can you do with it?
Great question. So black mass, it's a very generic but
just like something from Star Trek, I mean, oh no, here comes the black mass.
It sounds like a scary term, but really, it is a black mass. It looks like black powder. So the folks who recycle batteries, and I'm using air quotes right now, in the United States and within North America in general, take batteries and they shred them down. So they pull out, say, the copper, the aluminum, the plastics, and they're left with the active material. So it's really a mixture of the cathode and the anode. And the anode, right, is graphite or carbon. So that's why it's a black material that you see. So it contains all the really valuable materials. And that's actually what N-Cycle takes into our processes. We take that black mass, which again is generically seen as a waste product today, and we pull out all those valuable materials as individual products so that they can be then sold back into the supply chains.
So as you apply different currents to your filter, you can pull different materials out.
That's right.
Interesting. Now, the other question is, how do you potentially exploit all of that leftover ore and mine processing tailings from smelters and so forth? Is that another major source that we could dig into in order to provide all that cobalt and manganese, for instance?
Absolutely. So on average, there's about 30% of valuable materials that are left in these waste or tailings ponds, as they call them, around mining processing facilities that the upfront process couldn't pull out at the time. So their yields were only about 70%. So 30% of that material is just left for waste, and they sit in these very hazardous, sort of leach ponds. And they're extremely hazardous, and actually the mine companies are looking for ways to sort of clean these up, because they pay a lot of the fees to try and maintain them as is. And so if we can access those tailings ponds and retrieve the sort of leftover materials, that's a huge source for our supply chains.
Now, I lived near a former copper smelting location. It was actually at one point the largest Superfund project in the United States. And there is an entire neighborhood built on slag. Is that slag something that we should think about digging into too?
Yes, I think all of those different types of waste materials have a ton of those critical materials that we could go after, and we could help clean them up in the process.
So the last thing I want to talk to you about a little bit is that, you've done something really interesting here. You started Nth Cycle immediately after completing your PhD. But of course, you've been exposed to a lot of other problems. I'm just wondering what other opportunities have you seen that you think people should be thinking about? I could ask it as, what would you do next? But maybe you'll focus on Nth Cycle forever. What other problems should people be attacking if they're looking for a business opportunity?
Oh, that's a great question. So I think we touched on this earlier, is right in the disassembly of all of these big, and what is still phrased as is e-waste, right? If we think about EV packs coming off the road, or any type of large industrial equipment that is going to become electrified, right? All of these are massive battery packs, and there's really no automated way to disassemble them, right? Because all the recyclers, even Encycle, right? We need them in the form of black mass to be able to process them. We can't just take big packs out of cars and dump them right into our system. And so if anyone out there is even thinking about this space, it is a phenomenal space to be in. I think there's really little, if to no innovation right now, at least that I have seen or come across. So an automated process, and there are some big electronics companies that are working on this, but for smaller things like cell phones, there's really nobody thinking about how to automatically disassemble a pack into the different components that can be much more easily recycled.
So these are going to be good paying jobs too. One of the things we've learned as we've done research around the world about recycling is that societies with trash pickers are extremely efficient. But of course, they're societies with trash pickers, which is not a good fit for U.S. culture. But we're talking about an entirely new layer of recovery work that sounds like it can pay $20, $30 an hour. Is that a realistic assessment?
Yes, absolutely. And even not only on the scrap recycling side and really and growing that market, but also on the mining side, right? I feel like the US has fallen severely behind in that aspect as well, or less that market as well. And I think there are really great paying jobs if we can figure out a way to sustainably mine all the materials that we have here. Again, not using the very antiquated processes we talked about earlier, but right, those mines alone could provide, thousands of jobs and high paying jobs at that.
Well, this is a really encouraging conversation, I got to say. A lot of opportunity here, and particularly at the local level. I want to thank you very much, Megan, for taking time to talk with us today.
Yes, thank you, Mitch. This was great.
We've been talking with Megan O'Connor. She's the co-founder and CEO of Nth Cycle, and you can learn more about Nth Cycle, which is NTHCYCLE, nthcycle.com. This is a really interesting discussion in the context of what can we do to recreate our local economies, not just in terms of what we can do to transition to electrification. The whole notion of a circular economy is missing a step right now, and that step is taking stuff apart and making sure it gets to the right processors. And there's an immense amount of value in that role in the economy, as Megan pointed out. So if you're thinking about what you could do, whether as a business or just as a job, look at the recycling industry in a new light, because everything is about to change. We hope you'll take a few minutes to share this podcast and other Earth 911 podcasts with your friends. Get them thinking about changing the world too. And we will be back soon with another innovator interview. In the meantime, I'm Mitch Ratcliffe, your host. I've loved spending time with you. I know this podcast will be coming out right around Pod Giving. Thanksgiving. And I thank all of you for your attention over the course of the past 3 years as we have produced more than 250 of these conversations. This is Earth 911 Sustainability in Your Ear. I'm Mitch Ratcliffe. Take care of yourself, take care of one another, and let's all take care of our beautiful planet as we move into 2022. We'll be back soon.